So, you have an electrical field that varies with position and is determined by E equals the given equation right here. So then, if you place a particle at this given location with a mass of 5 grams, a charge of 100 millicoulombs, and the given initial velocity, we want to calculate the movement and position of the particle directly after being placed in the electrical field for several iterations. So then, to do this, we plug our starting location vector into the equation for our electrical field, and this will give us our vector for the electrical field, which we then multiply by the quanta of the charge to give us the force that is acting upon the particle from the electrical field. And we're going to say that this is the only force acting on our particle, so then that will equal our net charge. So we multiply those together and find that our force is equal to this vector right here. And then to update the momentum, we use our initial given velocity and multiply by the mass of the particle to find our initial momentum, which we use the momentum principle to add this momentum initially plus our net force that we calculated from the energy of the electrical field, and then multiply that, or the force from the electrical field, and multiply that times our change in time, which is going to be 0.1 seconds for each iteration. So then we do that, and that will give us our final momentum after 0.1 seconds of the particle. So then to find the velocity, the average velocity, we divide that by the given mass of the particle, which gives us our velocity, our average velocity after 0.1 seconds of the particle, which we then plug into our equation to update the location of the particle. So then our initial location is going to be this vector that was given at the beginning, and then we multiply our average velocity times the change in time, which is 0.1 seconds again, and this gives us our new location of the particle after 0.1 seconds, along with the speed of the particle, the average velocity after 0.1 seconds. So that tells us the information about the movement and position of the particle directly after. So then for 2 more iterations, we do the same process by updating the force from the electrical field based off the new location vector to update our net force, and then we will find our new momentum, divide that by the mass to find our average velocity, plug that into our equation to update the location, do that, use that again, plug that into this equation, use it to find our new force, use that with the momentum principle to find our new momentum, divide by the mass to find the average velocity, and then use that to find our new location that would be after 0.3 seconds.